Okay, let's look at this problem. A storm causes a pilot to follow a circular route with central angle of 12.8 degrees from city A to B rather than the straight line route of 185 kilometers. How much further does the plane fly due to the storm? So meaning that the pilot, instead of going a straight line, he chooses to go in a circular path. So we want to find how much further did it take him to get to city B from city A. So we can sketch that he wants to go from city A to B. So this is the straight line path. We can draw it like this, which is 185 kilometer. So A to B is 185 kilometer. That is via straight line. So we want to find out this. We can say it's an arc which he took, which is a circular path route, but they say that this path has a central angle of 12.8 degrees. So we can say that S, we don't know what is it, and then theta, we can say that is 12.8 degrees. So we can also bisect this line here. So by bisecting, what can we do? Because the main idea is to find distance S, which is the arc length from the knowledge of radian measure. So after we find distance S, then we can say S minus AB will get how much further does the plane fly due to the storm. So what can we do? We can extract a triangle inside that sketch. By extracting the triangle, we can extract one triangle. We say this is B and this is center. We can name this angle here beta. So beta is the half of theta, which theta is 12.8 degrees divided by 2. So 12.8 divided by 2 is 6.4 degrees. But of course we want to work with everything should be in radians. So we should put our calculators in radians. To convert from degrees to radians, we must multiply by pi over 180 times pi over 180, which is 0.1117 radians. So that is our beta. So distance OB is the half of 185. So 185 divided by 2 gives us 92.5 kilometers. So now that we have found OB, we can find the radius, because I'm recording. So sorry about that. We want to find the radius. So from here, this is the radius. Let's use the red marker. From here to here, it's our radius. And we can see that. How can we find it? If we say sine beta is equals to, it's equals to opposite over hypotenuse. Opposite that angle is OB divided by R, which OB gives OB is 92.5 kilometers over R. Then R will be sine, our beta is 0.1117 divided by, because we want to find R, so we have to divide by sine beta instead. So it's 92.5 kilometers divided by sine of 1117, which gives 92.5 divided by sine. Remember, the calculator must be on radian mode. So the distance, the radius is 829 8356 kilometers. So that is our R. So since we found R, then we know that arc length is given by theta R. So we can extend our drawing like this from the way it was given from the start. This is A, so this is S. So our theta, so it means that theta is equals to 2 beta, which gives 0.117 times 2. So theta is 2234 radians. So right now we can be able to find the arc length. It's theta R. Our theta is 2234. Then our radians is 829, let's confirm, 8356. 8356. 829, 8356, which gives 185.3853 kilometer. So to find how much further, we just have to say S minus AB is equals to how much further. Because of course the circular path should be actually longer than the straight line path if you are going from one point, one point to another, which is point A and point B they are the same. So here we have 185.3853 minus 185. 185.3853 minus 185, we get 0.3853 kilometers. So that is the answer. Thank you for tuning in.